Welcome to the SEI podcast series, a production of Carnegie Mellon University's Software Engineering Institute. The Institute is a federally funded research and development center operated by Carnegie Mellon University and sponsored by the U.S. Department of Defense. Today's podcast will be available at the SEI website at www.sei.cmu.edu/podcasts. Today, I'm here to welcome my colleagues, Robert Stoddard, Mike Konrad. I'm Suzanne Miller, principal researcher here. I've worked with these gentlemen for very many years. Actually, Mike was my boss at some point. So I'm very excited to talk to them about the work that they've been doing recently in a subject called causal learning, which they've been applying to a topic that we all care about, which is why does software cost so much? And before we get started into that discussion, give the rest of the audience that don't know you as well as I do a little bit about why are you here at the SEI, what brought you here, and what is it that brought you to this particular research? So Robert, let's start with you.
So I've been at the SEI about 13 years after 24 years in industry. And I came to the SEI because I really wanted to become a scholar practitioner, work on my PhD, which was a lifelong pursuit, and still make use of my industry background. So I've been working at the SEI in statistics and probabilistic modeling, and now machine learning and causal learning, and have a great time working with Mike.
Excellent. Mike.
So I've been at the SEI for about 30 years. Why did I come to the SEI? That's long ago history now. But,
what brought you to this research that you're doing now?
Yeah. So I've been fascinated by, I guess, architecture and requirements and how they meet with in safety and security critical systems, and trying to wondering about how to do that better, how to apply what we think we know about design and quality in a some kind of systematic way to better achieve good quality results with software. And so causal learning seemed to be a way to make sense of the soup of the many factors that affect that.
So that takes us into the subject of causal learning and how is it different from other kinds of learning methods that apply in other settings like machine learning, statistically based learning methods. Causal learning actually has more of an intervention kind of aspect to it than some of these other methods, which I think distinguishes it from things pretty clearly, that we're not just looking at what do we learn from this data, but how does this data guide us to make a different policy decision, make a different tactical decision. So to me, that's the fascinating thing about it. So tell us more about what is it and how is it different from these other methods methodologically and also in terms of its use.
So, and just to clarify, the intervention part is what we seek to educate. We want to educate through causal learning what interventions one could take to change outcomes. Yes. But the methodology actually can be applied to both experimental data and observational data where we really don't have the ability to run a controlled experiment. And most of our topics, that's the case. So we do want to empower the decision maker to know when to take action, when not to take action.
And some of this is because of the multi-factor, as Mike mentioned, multi-factor nature of these environments. When we can't do a controlled experiment, we're left with lots of different factors affecting, and you're trying to help clarify what are the factors that we may want to pay attention to.
Right. So the causal learning is going to go beyond the correlation and regression and actually let us get a chance to see which factors are really causal in nature versus just correlated. And so we have a notion of correlation that can be misinterpreted and it's not really causal in nature.
So we have the statement in the statistics world that says correlation does not imply cause, right? We all learned that in our first statistics class. And what you're trying to do is sort of help us understand when does correlation have more meaning and when can we take it farther. So how do you do that?
So as our coach, Professor Danks over at CMU in the Dietrich School of Humanities, he's the head of the Department of Philosophy and have all the experts in the causal learning. He's basically, espouses that correlation is a noisy indicator of causation. And so it's still helpful. We're not saying to disregard correlation, but causation is where we want to go. And it is related to machine learning, all that Mike.
So a simple example, if you were to look only at simple correlations, you would find that, or it was found that in New York City, serious crime and would occur at would go up when ice cream sales would go up, and so one might look at a causal explanation for that, but one might instead recognize that there are other reasons why correlation might be there, and in this case maybe it has something to do with summer or heat or warm outside, and that's where you bring criminal and maybe victim in closer proximity, and people buy ice cream. So it turns out that there are statistical tests that you do for correlation that inform you also about whether there is in fact a causal relationship between variables. So there's those related to what's called conditional correlation and those related to the say information theory. So those are ways of actually ascertaining something which we would call causality.
So what drove you to start focusing on causality as a topic? Because we've been trying to deal with learning of varying natures, but this is fairly recent, in the last 5 years that you've been working on that.
Sure. Okay. Let me take that one first. So several years ago, we came out with guidance to help organizations on their high maturity path. Mm-hmm. But a lot of that guidance was actually based on correlation. And what organizations were trying to do, and we were encouraging organizations, was to use results from their inspections or peer reviews and tests to guide when to take some kind of action because maybe quality wasn't good enough or maybe quality was fine. So what we initially were prescribing they do was look for correlational information. But then you have the hidden summer variable thing that I was mentioning. You have other factors that might explain why things are correlated. And there was no guarantee that by taking certain interventions that you would make things better. Right. You only were playing into the known correlations and not the issue of summer. Gotcha. If you can follow, so if that analogy is clear. So what really it was very strong motivation to try to understand exactly what was happening so that we could help organizations make sensible changes, interventions in their project to help guide them towards success. Okay.
And like Mike said, our journey started with predictive modeling for high maturity organizations. And as we studied that, we were jumping into a lot of probabilistic modeling and Bayesian modeling, and then we became big fans of Dr. Judea Pearl. And then in 2015, he came on site to CMU when he was awarded the Dixon Science Prize at CMU. And that's when we learned that after a lifelong work in Bayesian probabilistic modeling, he had come to the enlightenment that causal learning was really the end that he should have been pursuing. And that it goes beyond just prediction, but actually having a model that you can take action and change outcomes.
Okay, so all of this research, this is what we do, take all of this learning from different sources and apply it to a real problem. Right. And so the real problem that you are working on right now is the title of this podcast, Why Does Software Cost So Much? And so what is it about causal learning that makes you think that it will help you in answering that question better than we've been able to answer it for the last 30 years, because we don't have good answers for that?
Well, very simply, it's easy to find correlations when it comes to software. It's just that we don't know which ones are actually having this causal relationship. And yes, we've been building software for several decades, and we find lots of correlations. And therefore, it's almost, as Bob said earlier when quoting Professor David Danks, correlation is a noisy indicator of causation. So what do you change? What do you do differently? Do you send people to more training? Do you is now a good time to replan? Do you throw in better staff, do some mentoring, do you buy a new tool?
Right.
So those are the kinds of decisions that need to be made. And right now, people are just guided by their experience and correlation. And neither is that great of a guide. So we're trying to get a more established, more systematic approach to understanding what changes to make to improve project success.
I think additionally, this is enriching our research here at the SEI, and we hope across more research at the SEI. But I firmly believe that this methodology lets us do a better job of filtering out what are truly causal factors versus non-causal factors. And my belief is in most areas of research, up to like 80% of the factors that people think are related because of correlation are not causal. And so we really think that we're going to help research move forward by focusing on the ones that we believe are causal in nature.
So in the past, if you wanted to do root cause analysis, right, which we have done qualitatively, you kind of ask the 5 whys and you do things like that. What is it that you do differently? How do you use the data sets that are available, rich data sets that are available that give us different kinds of information to kind of go beyond that qualitative sense of this is probably the cause to something that is more statistically based, more research based?
So going back to that example of serious crime, ice cream sales, and summer, if you looked at the 2 variables of serious crimes and ice cream sales, you'd find them correlated. But if you conditioned on what season it is, you would tend to find them uncorrelated. So that's a signal that summer has some kind of role between ice cream sales on the one hand and serious crime on the other. And so it's that kind of generalized pattern that we look for, or the algorithms we use that were developed by individuals like Peter Spertes, Clark Gleamore, also with the Department of Philosophy on campus. These were invented concurrently with Judæus Pearl's work that Bob was speaking of earlier, that helped put causal learning on a more systematic setting. And now there are several dozen algorithms, and through the Center for Causal Discovery, which is a joint effort of Carnegie Mellon and University of Pittsburgh, and several other universities through NIH funding, these dozens of algorithms provide a basis for any researcher, other research done at the SEI included, that will help Bob and I contend, help provide a more robust and systematic approach towards observational type data, which is often what we have in software engineering, and identify the causal patterns that seem so important for designing methodologies and analysis algorithms and so forth.
So another way to explain this, if I have it right, is that you look at conditions like both of these ice cream sales and crime increases occur in summer. So if we take summer out of the equation, are these then correlated?
Right.
And so what you're doing is this systematic process of elimination of, okay, here's a correlation, here's another factor that they're both correlated to. Is this something we can take out? And then what you're left with are probable causal factors, although you have to do more analysis to actually establish that, correct?
Right. Now, of all, the dozens of algorithms that Mike mentioned in the tool called Tetrad, the algorithms use different approaches to identify that causation. One other simple example of how some of the algorithms work is, if you have a factor X causal on Y, supposedly, if you run regression, you'll get a set of residuals. Then if you have the 2 factors change places and run regression again, you'll get another set of residuals.
Well, that's
and if you compare the 2 sets of residuals, you can conclude which direction the causality is. So there's a number of techniques within these algorithms that help them define the causal links.
So let's pull it back to cost and software. What are you finding when you start looking at that particular problem and all the data that we have? How does causal learning help us get some insights that we may not have had before?
This is a 3-year journey, and actually 4 years, because Bob led the initial exploratory research effort, and now we have a further 3 years. And we are looking at data sets that we have here at the SEI and those with our various collaborators and colleagues. So for instance, we've looked at the personal software process data and found some reasonable support for a hypothesis that Dr. Bill Nichols, a colleague of Bob and myself, and I've had, that there are human traits that manifest themselves in programming in terms of a type of problem-solving characteristic that we might think of as productivity, and then also defect proneness. And those traits can be modified through learning, through training, but they are also very predictive of what happens. And so we have, behind our current research, we have a kind of theory about how these come together to for individuals to create code, choreographed by a plan or a project team and in the roles and responsibilities assigned. But that's what our research is trying to elicit through looking at, for instance, the personal software process data set, and another data set with another research collaborator, Dr. Sarah Sheard. It was looking at the role that complexity has, complexity in the environment or context, including stakeholder relationships, complexity in the architectural solution, complexity in terms of using emerging technology in the solution, and what that does relative to cost. So we've been looking systematically at several data sets, and Bob has as well. And we have some initial, again, early stages, but some initial results that are kind of intriguing, and I'll talk about some. But Bob, why don't you tell them?
Yeah, so one of the things we're finding on this project is that we need data to do this. And so there's not like a lot of great data just floating around to use. So we have several approaches to deal with that, and that's spending up a good part of our team's time as we got started to beat the bushes for collaborators to have data and all that. So we recognize that we're often going to access data that is a little bit disjointed, but we know from our coaching from the CMU faculty, there are ways to stitch these causal structures together towards a holistic model. So a recent data set I'm studying is from a client where they had a survey taken by 30 staff members each week for a year and a half. And it had a lot of the factors that I had data mined out of Watts Humphrey's book on leading TSP teams that were basically unmeasured but discussed in his book. And so we've studied those, and the interesting thing is, we're looking at outcomes of cost, schedule, and quality by these team members, their perception of how it's going on the project for that week. And analyzing that data from a correlation standpoint, anywhere from like 16 to 18 of the factors are correlated highly with cost, schedule, and quality. But when we do a causal structure analysis, one of them was causal on cost, one on quality, and none of them were causal on schedule. So that's a pretty dramatic early example
that's exciting.
of what we're getting out of this.
That's very exciting, because I know project managers that I've worked with in various client settings are always looking for what are the levers. They talk about what are the levers, what are the leverage points, and if we can help them eliminate the ones that are not causal, then that allows them to focus. I mean, there's a whole lot of implications for that if we have structures that we can trust. So that comes out to the next question is, how do you build trust in these causal structures? There's algorithms that sort of get us to a point where we have some idea, but to socialize these into something someone's going to use, have you guys been thinking about that yet, or is that kind of more in the future for things you need to think about?
So we're doing several things to build confidence in the results that we're getting, and it's an ongoing process. We're looking at a variety of different data sets, often where we know the provenance and have some confidence in the provenance. We're looking, as Bob mentioned earlier, at overlapping data sets that collectively inform us.
Okay.
No one data set might be in itself complete at capturing potential candidate causes of interest. We're using different algorithms that work on very different principles. So I mentioned information theory earlier as an example, and the other one on the conditional independences within the data set. And those two are relatively different approaches towards teasing out causality. And then we're also, so there's that.
Right.
And then also we're just, frankly, we're also building on the history of use of causal techniques in other domains where they have had success.
Okay.
And so we're basically arguing there's nothing so fundamentally different about this data. All data is different. But there are some similarities in terms of information theory and independences that we are all capitalizing on, whether we're talking about medical discovery or discovery of software engineering factors that matter in terms of cost, schedule, and quality. And incidentally, on a data set that Sarah, that I shared and I've been looking at, we found this concept called cognitive fog, which is where you have a lot of maybe internally inconsistent data and cognitive overload as a factor that predicts what Sarah calls performance gap. So this is a kind of quality measure, whether you meet the technical requirements on the project. And cognitive fog seems to causally mediate on that, affects that performance, which also relates to project success. So we have those two outcomes, project success and performance gap, that are predicted by cognitive fog, which occurs maybe about midway in a project. And in turn, cognitive fog seems to have as its cause number of decision makers. So here we could see, as we refine this understanding. So the old adage,
too many cooks spoil the pot, actually may have a research basis.
Yes. So these are early. The data sets are small. So we are not yet ready to make this base any particular policy on this or encourage that. But we are finding things which do meet certain familiar sayings or heuristics and truisms. And anyway, and I'll just say that.
And your question about confidence, it really highlights a second reason we're looking for collaborators. One is to have access to data, but the second one is, and this is back to the CMU coaching, once we have a causal result, the number one way you can go increase confidence is if we can go get a collaborator in the real world, in the field, to actually take action based on what our causal structure is saying and see a difference in a result. And so we're working with collaborators, and we're presenting next week at the Acquisition Research Symposium to this week actually to get collaborators that actually would agree to do the second part.
Right. Mike?
And our collaborator Anandi Hira at the University of Southern California at Barry Bames Center for Systems and Software Engineering will both be, actually she'll be presenting some of her joint research that she conducted.
Excellent.
And actually the data she studied, we've taught them how to do causal learning, and they have some interesting results on projects, real projects, but done by students. They have the ability in a quicker time frame to have the students take change on causal factors and give us the results. So.
Oh, that's nice. Yeah. So that, so you've got some short timeline. Many of the projects, certainly in the DoD, are of the much longer time frame. So the delayed effect of change is one of the other things that you have to deal with. So this is pretty early. Your first year of a 3-year project. But many of our listeners and our viewers get very interested in learning more about the subject that we're talking about. And so have you thought about sort of what are some of the ways that people can learn about causal learning? In a more general way, do you have any plans for kind of transitioning this out into a larger either research community or just in the larger DoD community?
So I'm going to let Mike talk about some of the actual technical training that's available now, But I would lead off by saying that I'd like the audience to start realizing correlation is not the stopping point. And when you hear about research results on NPR in the morning, they always stop at correlation. I'm like, go the extra step. Tell me what's the causal result so I can really believe it. Otherwise I'm not really going to change my diet. And so I just like folks to become aware that causation is important, and don't just think correlation is always the answer. The other thing I would mention is we recently posted an SEI blog on this topic, and at the end of that blog, I think we have like about 15 links to books and tutorials and things like that. So that's like one-stop shopping. It's the kind of blog I wished I'd had 3.5 years ago when I started my journey studying causal learning.
Fair.
So, but I'll let you talk a little bit about the.
So I mentioned earlier the Center for Causal Discovery, and you can find their website either searching within a Google search window or within YouTube, CCD, and maybe add the word causal so you don't discover some form of music you didn't realize existed. And so search for CCD and the word causal, and you will find that there are videotape sessions of Professor Richard Chinus presenting 13 videos or lectures on causal learning, so you can learn causal learning. And they are, and Bob's already mentioned the Tetrad tool, which has those algorithms implemented through a friendly GUI interface. The Center for Causal Discovery also provides an API, so for those wanting to write programmatic solutions, they can do so.
Okay, so there's already material for learning this, and what people should look forward to is your reports in the future about how we can apply this in the software engineering community to answer some of our questions.
And there already are some publications out there that just came out through Anandi Hira and others that we'll be doing in the next few weeks, actually.
But I would say, we've done extensive lit search to see who else has been using causal learning, and in the United States right now, it's most heavily used in cancer research. A small pocket of economists are using it, and then a moderate-sized group of psychologists, sociologists are using it for government social policy. But from what I can tell, in the engineering and the engineering research side of the house, I think we're precedent-setting on that. And I really hope that SEI will be at the top of the FFRDCs for using such a rigorous methodology in research.
Well, and as you said, we have access to some software data that is not prevalent within the industry as a whole, so we have a little bit of a leg up on that. But I'm glad to see us using it.
So Bob mentioned different kinds of algorithms earlier, so for discrete data versus continuous. But there's also for time series data, so an application there of causal learning for the past few years has been in applying causal learning to fMRI data. So in particular, brain imagery to see which areas of the brain get activated.
Functional MRI data.
Functional magnetic resonance imaging.
Good. Okay, so lots of different avenues for this. What do you see as, once you've figured out sort of how to use causal learning to answer some of these questions, what do you think is the next thing that you're going to want to do with this? What's your dream?
On my own time, it'll be the stock market. But
there's an application of causal learning. You better not be the next one that makes the mortgage industry crash. You're not allowed to do that.
But after this project, and we have a restricted research project going on with the Air Force on applying machine and causal learning and understanding the benefits to use them together. But I see a number of existing and planned research, both in CERT, cybersecurity, and in the Software Solutions Division, that would definitely benefit from using this. And we've started working a little bit in the technical debt area with Rick Kaisman and EPEC. So
I was thinking about CERT because I was thinking about all the, in many ways, the security problem is too much data, lots of correlations, and not enough understanding of where the causal, which things we can eliminate. So that could be a very fruitful area.
I think insider threat would definitely be a good area.
Yeah, that would be one. I want to thank both of you for joining us today. I get to see you in the halls, but I don't get as much time to talk about your research as I would like to. So this is really precious
Likewise.
for me.
It's precious for me,
so-
and I'm sure
Yeah.
Bob as well.
So
It's nice to see people other than the airport.
there you go. Yeah, so don't go there. I do want to let our audience know that the blog post that you mentioned is out there. If you search in the SEI blog at insights.sei.cmu.edu and search for Stoddard, Stoddard, then you should be able to find his blog post. And I'm sure that you will enjoy it as much as I did.
Thanks.
So we will provide links to the resources mentioned. There's a few things we talked about here that we'll add into the transcript that may not be in the blog post so that our audience has access to all of that.
Okay.
And I will remind everyone that our podcast is available from 3 sources. You can get it at the SEI website at www.sei.cmu.edu/podcast. You can get it at the Carnegie Mellon iTunes U channel. And you can also get it on the SEI's very own YouTube channel. So you're going to be on YouTube. You can tell your kids.
Wow.
As always, if you have any questions, please don't hesitate to contact us at info@sei.cmu.edu. Thank you for viewing.